Good day, learners. Welcome to mathematics lesson. My name is Nonkululeko Mboyisa. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. In today's lesson, we will be looking at statistics. At the end of the lesson, you should be able to determine the standard deviation manually and using a calculator in an ungrouped data. Number 2, you should be able to determine the data set that falls within one standard deviation. Number 3, you should be able to determine symmetrical and skewed data. Number 4, you should be able to identify the outliers. Before we can move on to our today's topic, firstly, you should be knowing, by now you should be knowing how to calculate the mean. You should be knowing how to determine the 5-number summary, of which we have done the work before last. Number 3, you should be knowing how to sketch box and the whisker diagram. Number 4, you should be able to find symmetrical and skewed data. Let's first look at the variance and the standard deviation. So variance is a useful measure which is used to determine the standard deviation. The standard deviation, remember we spoke about it when I was still introducing the measures of central tendency and the measures of the measures of dispersion. So the standard deviation is one of the measures of dispersion. It's a representation of how much variation or dispersion there is around the mean. So you can either have a low standard deviation or a high standard deviation. So if you have a low standard deviation, that shows that the data points, they lie close to the mean and the data set is generally consistent. And if it's a high standard deviation, it shows that the values, they spread out over a large range and the data is not consistent. Okay, so we have two formulas. We have the first formula, which we use to calculate the variance, which is that d, which is facing the other direction, squared. It is equals to the sum. Remember that sign, it means sum. The sum of the data value minus the mean squared all over 2. So how do you use your variance to find your standard deviation? So whatever that you have here to find the standard deviation, if you can notice in the formula for standard deviation, there is no squared. So it means for you to find the formula of the standard deviation, you have to put a square root here and also put a square root to the side so that you can find your standard deviation. So after you have found your variance, you can just use your variance to find the standard deviation by just putting a square root both sides. Then the formula for the standard deviation will be that d, which is facing the other direction, is equals to the square root of the sum of the data value minus the mean all squared all over the n. So your x, you must know that your x in that formula, it stands for the data value that you are given. So that data value that you are given, we call it the x. And then the x bar, already you know what is an x bar. The x bar, it simplifies the mean. And then n, it's the sample size or the number of data points in the sample space. Ne? Okay, let's move and look at example number 1. Calculating variance and the standard deviation manually. So for now, we are not using the calculator, but we are finding the standard deviation and the variance manually. Ne? So the table below shows the results of a COSA test of a grade 11 class. So you've got a learner who obtained 52%, you've got a learner who obtained 44%, you've got a learner who obtained 62%, and you've got a learner who obtained 66%, and then you've got a learner who obtained 60%. Okay, let's go through the questions. So number 1, it says calculate the mean mark for the class. So obviously you know how to find the mean by now, right? So we said the mean, it's x bar. It is equals to, you add each and every value there and then you divide by the total. So it means you will have 52 plus 44 plus 62 plus 66 plus 60. It's all over 5 because the number of values here, they are 5. You have 1, 2, 3, 4, 5. So you divide by 5. So your x bar will be given as 56,8. You can just double check with your calculator and make sure that my answer is correct. You say 52 plus 44 plus 62 plus 66 plus 60. You say it's all over 5. Okay, it is 56,8. Moving to the second question, now they're saying complete the table and use it to calculate the standard deviation of the marks. Remember, in your exam, maybe they wouldn't say find the mean first and then find the standard deviation, or maybe they give you a table, they say complete it to find the standard deviation. When you are finding the standard deviation, you just need to know that if you are doing it manually, you need to find the mean first without anyone having to tell you. Ne? Okay, so we said to the x, it stands for the data value that you are given, and then the x bar, it stands for the mean, right? So it means you'll say 52, which is the data value that I'm given, and then I say it's minus 56,8, which is my mean. Okay, so 52 minus 56,8, that is going to give you negative 4,8. So the answer that you get, you must square that answer. So it means you will have negative 4,8, then you square. You should get your answer. Okay, and then the next data value, which is 44, it means you are going to say it's 44 minus the 56,8. Okay, punch that in your calculator. You'll say 44 minus 56,8. And then you'll get negative 12,8, and then you square. Okay, the second one, 62 minus the mean, which is 56,8 again. It is going to be 62 minus 56,8, and we're getting 5,2. You square so that you can get your answer. And then the next one, it is going to be 66 minus the 56,8. That is going to be 66 minus 56,8, and you are getting 9,2. Then you square again. Okay, and then the last one, it is 60%. So you'll say 60 minus the 56,8. So it is going to be 60 minus 56,8, and you'll get 3,2. So after getting all of this, the answers that you are getting, you need to square them, right? Remember, in your formula, we said you are finding the sum of x minus x bar and then squared. So here we only got x minus x bar. So the next step is to find the squared. So now we need to square. Remember, when you are squaring, you need to put it inside the bracket so that this negative could be affected by that too. There's a difference from when you are saying negative 4,8 squared and when you are saying negative 4,8 and then you square like that. Ne? Make sure you put it inside the brackets. This one is incorrect. Make sure you put it inside the bracket so that that negative could be affected by that squared. Okay, so negative 4,8, if you square it, you are getting 23,04. You see my answer is going to be positive because I decided to put the brackets. Ne? And then we move to the next one. It is negative 12,8, and that is going to give you 163,84. And then we move to the third one. You have 5,2. 5,2 will give you 27,04, right? And then move to the next one, which is 9,2. It is going to give you 84,64. And then you move to the last one, which is 3,2. And it is going to give you 10,24, right? Okay, you are not done. We said we are finding the sum of this. So it means you have to add everything going down so that you can get the sum of everything. Ne? So the sum of x minus x bar squared, it is going to be given as, let's add everything. So you'll add your 23,04 plus your 163,84 plus your 27,04 plus your 84,64 plus your 10,24. Okay. Let me start afresh. I am getting 308,8. I don't know if you also got 308,8. Okay. So remember the formula for finding the variance. We said it is going to be that squared. It's equals to the sum of x minus the x bar, and then you square all over the total number. Ne? Okay, so it means I will have, let me see if I've spaced this side. Okay, this is for something else. I'll just erase what we have done so far then. I need a little bit of space. Okay, so I'm going to continue from here. I'm going this side. Okay, so my delta squared, it is equals to that sum of everything. We said it's 308,8 divided by n. So it means that squared, it is equals to the total number there, it is 5. So you divide it by 5 and you will get 61,76. Remember, this is your variance. So for you to find the standard deviation, now you just say the variance that you had, you just square and you put a, sorry, you just put a square root and you also put a square root. So you, that, okay. So if I put a square root to the side and I also put a square root to the side, I'll get my delta is equals to the square root of the answer. It is going to give you 7,86%. So first things first, you need to say the data value minus the mean for each and every value of your data set. And then on the other side, then you square what you got to the side. So whatever that you got here, you square, you square, you square, you square, you square. After that, you add everything. After everything, then you divide by the total number. Then you will get your variance. After getting your variance, you can use that variance to get the standard deviation by just putting a square root and also putting a square root. Ne? So in this case, our standard deviation is given by 7,86%. Then let's move to number 3. It says how many learners fall within one standard deviation of the mean. Okay, so the number of learners that fall within one standard deviation of the mean, you'll say it's your standard deviation. Sorry. Let me use red. Okay, so we say it's your mean minus your standard deviation is to your mean plus your standard deviation. Okay, so let's go back. What was our mean? We got that our mean was 56,8. Ne? So our mean is 56,8 minus our standard deviation, it's 7,86, is to your mean, it's 56,8 plus your standard deviation, it's 7,86. Ne? Okay, so you'll say it's 56,8 minus 7,86. and you'll get 48,94, 56,8 plus 7,86. You will get 64,66. So the numbers that are the learners that are going to fall within one standard deviation of the mean, they are going to be between 48,94 and 64,66. So we go back to our data set and check which of those numbers or those learners fall within 48 and also the 64. Okay, so I can see the 52, it falls between the 48 and the 61 and the 64, sorry. And then the 44, it's less than the 48, so it's outside one standard deviation. And then you move to 62. 62, it's between your 48 and your 64, so that one is in. And then your 66 is above the 64, so it means this one is out. And then your 60, it's also within one standard deviation. So here they only asked you how many learners fall within one standard deviation. So we got that we have 1, 2, 3 learners that falls within one standard deviation. So you just say your answer is 3 learners. Sometimes the question could come as how many learners fall outside one standard deviation. So if it's outside, you will be checking the number of learners that got marks that are less than 48,94 and marks that are above 64,66. So always, if it's within one standard deviation, it should be between the mean bar minus your standard deviation, and then your mean bar plus your standard deviation. I hope you understand that one. So let's look at activity number 1. This one, you are the one who are going to be doing it for me. It says the table below shows the amount of time that 8 grade 11 learners took to complete a race. So number 1, they say complete the table and use it to calculate the standard deviation of the marks. So you are given 12, you are given 19, you are given 40, 33, 25, 24, 15, and 38. So please use that table to calculate your standard deviation. So let's use that table to calculate our standard deviation. Remember, I said to you, you need a mean so that you can find your standard deviation manually, right? Okay, so before I can do anything, I need to find my x bar. So you'd say your x bar, it is equals to, remember you add everything and then you divide by the total. So it is going to be 12 plus 19 plus 40 plus 33 plus 25 plus 24 plus 15 plus 38. So I added everything and then I divided by the total number, which is 8, right? So my x bar will be given as 25,75. Done. And then from there I can use that mean to find my standard deviation. So first things first, you take your data value that is given this side. In this case it's 12. You say it's minus the mean bar, which is 25,75. Then you shall get your answer is 12 minus 25,75, you square. You get negative 13,75. Then you move to the second one, you are given 19 minus 25,75. It is going to be negative 6,75. And then the third one, you are given 40 minus 25,75. Okay, that is 14,25. Then you are given 33 minus 25,75. It's going to be 7,25. Then 25 minus 25,75. It is going to be negative 0.75. Okay, you move to 24 minus 25.75. 24 minus 25.75, and you get negative 1.75. You move to 15 minus 25.75, and also 38 minus 25.75. Ne? Okay, so that is going to be 15 minus 25.75, and it's going to give you negative 10.75, and then it's going to be 38 minus 25.75. It's going to give you 12.25. So don't forget, you are squaring, and when you are squaring, make sure you put everything inside the bracket. Okay, so I'll start with the first one, negative 13.75, and then I square, I get 189.0625. And then I move to the second one, it's negative 6.75, and then I square. It is going to be 45.5625. Then I move to 14.25, I square. I'll get 203.06.25. I move to the 7.25, and then I square. I'll get 52.5625. Then negative 0.75, you square. You'll get 0.5625, ne? And then negative 1.75, you square, you'll get 3.0625. Then we move to negative 10.75, then you square, you'll get 115.5625. Then the last one, it's 12.25, and then you square, you'll get 150.0625. Okay, so if I add everything here, I will get 189.0625 plus 45.5625 plus 203.0625 plus 52.5625 plus 0.55625 plus 3.0625 plus 115.5625 plus the last one 150 plus 0.6225. So I am getting 759. Let me just write it down here. 759.5. Okay, so let's look at our equations. So our equations, we said, is going to be that delta squared, it's equals to the sum of x minus x bar, and then you square all over n. Okay, so that is going to be that the sum of all of that, we said it's 759.5. You divide it by the total, which is 8, then you'll get your answer. So the answer divided by 8, you get delta squared, which is equals to 94.9375. Remember this is your variance. They said we must find the standard deviation, so it means we need to continue, né? So you put a square root and you put a square root, then you'll get that your standard deviation is equals to the square root of the answer, which is going to give you 9.74. So it means your standard deviation is given as 9.74. Ne? I know it's a lot of work. I hope we all got the same answer. Okay, let's move. And then it says, how many learners fall within one standard deviation of the mean? So I said to you, it's going to be x bar minus the standard deviation is 2, x bar plus the standard deviation. So your mean bar, it is given as 25.75. 25.75 minus your standard deviation, which has calculated it now, it's 9.74. Then on the other side is 25.75, 25 plus 9.74. Okay, so I'll have 25.75 minus 9.74, and that is going to give you 16.01 is 2. 25.75 plus 9.74, that is going to give you 35.49. So it means we go back to our data set. We are going to look for the learners that fall within 16 and 35.49. So they should be above 16 but less than 35.49. Let's go back. Is it less than 15? Is 12 less than greater than 16? No, so this one is out. And then is 19 greater than 16? Yes. And then is 40 greater than 16 and less than 35? No. So that one is out. And then is 33 greater than 16 and also less than the 35? Yes. And the 25, yes, it's also in. The 24, it's also in. The 15, no, it's not in, because we are looking for the values that are greater than 16, right? And then 38, let me see, we have 35.49, so 38 is above, so it means this one is out. So the only learners here who are going to be included in that that are within one standard deviation is going to be 1, 2, 3, 4. So we've got the number of learners, it's 4 learners. Done, and you get your full marks. Okay, so now let's use a calculator. Make sure you've got your Casio calculator with you so that you can see how we use a calculator to find the mean and the standard deviation. Normally in your exam, you'll notice that the question of finding the standard deviation is just 1 mark or just 2 marks. So just use a calculator so that you don't waste time by completing those 2 tables and also just making mistakes. Just take your data set and put it in your calculator, then you'll just find the answers from there. Okay, so how do you use your calculator to find the standard deviation and also the mean? So first things first, let's just look at example number 2. Let's just go straight to example number 2. And then in example number 2, we need to insert that data set in your calculator. Ne? So first things first, you need to go to mode setup. In your calculator, you must press mode setup. If you press mode setup, you'll see number 1 as comp if you are using the Casio, and then you'll see number 2 as stats, and then you'll see number 3 as table. So since you are dealing with stats, you'll just press number 2, which is stats, and then it's gonna give you a list of options in stats mode. So you'll get number 1, of which it's 1 var, and then you have 2, which is a plus b times x, and then you have the other list name. So what you are interested in, since you are going to substitute, or rather you are going to enter a single data, you will substitute, you'll press 1 for var. So choose 1 for var, you'll press 1. Then it's gonna take you to a table that looks like this. It's gonna be the number of values 1, 2, 3, 4, and then it's gonna be a table like this, and then it's gonna be x up there. So for you to substitute, or rather to enter your values, you will need to substitute you enter your value. Let's say for instance you're entering 52, you'll say 52. Then to enter that value you need to say equal sign. So let's go back to our data set. So you substitute the 52, you say it's 52, you say equal sign so that it can enter in your calculator. You substitute 57, then you say equal sign, you substitute 100, and then you say equal sign, you substitute 55, and then you say equal sign, and then you go to 44, then you say equal sign, and then you go to 95, then you say equal sign, and then you go to 69, and then you say equal sign, you go to 32, and then you say equal sign. Just substitute each and every value until 18. So I'll substitute my 62 equal sign, 78 equal sign, 62 equal sign, 83 equal sign, 66 equal sign, 71 equal sign, 72 equal sign, then 78 equal sign, 60 equal sign, 62 equal sign, 73 equal sign, and then it's 80, and then it's equal sign. So you insert your data set up until the last one, which is 18. So after doing that, you can just, after you have entered your data set, you can just press AC, or you can press on. It's up to you, on, or you can press AC. It's gonna give you the same thing. So if you press on, you will notice that it's just gonna show you a 0 in your calculator. And then on top of your calculator, you will notice that there is stats and D. So if there is that stats, it means that data set that we are inserting, it's already in your calculator. So it means now you can work with your calculator, you can work around your calculator and get any value. You can get the minimum value, the maximum value, the standard deviation, you can get your mean point, you can get anything. Okay, so now we want to find our standard deviation, or you want to find your mean, or you want to find your maximum value, or you want to find your minimum value. But in this case, let's just focus on standard deviation and the mean. Okay, so how do you go back? How do you access your data set? So you will press your shift. If you press shift, there will be a smaller S there on top, and then you press 1. So you press shift, then you press 1. If you press shift and 1, and then you'll see number 1, it's type. Number 2, it's gonna be data. And then number 3, it's gonna be sum. And then number 4, it's going to be var. And then number 5 is gonna be mean and max. So if you are looking for your minimum and your maximum value, you'll go to number 5. But in this case, we are dealing with that variance name. So you press number 4. So if you press number 4, you will notice that you get the 4 options. 1, you have N. 2, you have the X bar. And then 3, you have your standard deviation and X. And then you have 4, which is just that X, the SX. Okay, so since, let's say we are looking for the mean, you can just press 2. If you press 2, you will get that your X bar. If you press 2, you will get that your X bar, it is given as 67.55. And then again, you press your on, or you press your AC, then you go to shift again, and then you press 1. You'll go through the same process. You go to number 4, and then in number 4, since now you want to find the standard deviation, you just press number 3, and if you press number 3, it's going to give you a 0. Then you say equal sign. If you say equal sign, then it is going to give you your standard deviation is 15.75. It's 753, or you can just write 15.75. Then yeah, that's how you enter your stats, or rather your data set, and then that's how you find your standard deviation and your mean. Okay, so now in your calculator you've got that stats and that degree. So you need to make sure that you erase all of that so that you can be able to use your calculator again. So you say mode set up again, and then after pressing mode setup, you'll see number 1, which is comp, number 2 stats, and then number 3, which is table. So you press number 1, and then your calculator is gonna go back to degree and the maths. Ne? Okay, so now I move to B. B, it is saying determine the percentage of learners whose marks lie within 1 standard deviation of the mean. So now they say we must determine the percentage of learners whose marks lie within 1 standard deviation of the mean. So we said for learners to lie within 1 standard deviation of the mean, we are going to say it's your x bar minus your standard deviation is to your x bar plus your standard deviation. It should be within that, right? Okay, so your mean, it is given as 67.55 minus 15.75 is 2. And then your mean, again, you substitute your 67.55 plus your 15.75. Okay, so let's punch that in our calculator. It's 51.8, and then the other one is going to be 67.55 plus 15.75, and then you will get 83.3. So it means in our data set we are going to look for the values that are above 51.8 but less than your 83.3, right? Okay, so 52 is above 51.8, okay, and it's less than 83. 57 is also included, but 100 is not included because it's above the 83.3. 55, that one is in, and then 44, it is less than 51, so that one is out. 95 is also out because it's above 83.3, and then 69, it's in, and then 32, it's less than, so it's out. 62, it is above 51.8 and still less than 83.3, so that one is in, and then 78 is also in. 62 is also in. 83 is also in because we are looking for the values that are above 83, the one that are less than 83.3, and here 83 is less than 83.3, right? So it means 83 is also included, and then 66, it is also included. 70, 71, 72, 78, 60, 62, 63, and then 73, and then also your 18. So it means you'll have how many values here? You will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think we made a mistake somewhere. Let me check. 60 is in, 62 is in, 73 is in, 80 is in, 66 is in, 71, 72, 60, 78, 62 is in. Oh, yes. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I don't know if it's 17 or it is 16. Just double check for me. Okay, so I am getting 17, so it means it's going to be 17 learners, right? But now they said I must find the percentage of learners. So for you to find the percentage, you'll say the number of learners that fall within 1 standard deviation, and you divide it by the total number of learners. How many learners do we have there? They 20, and then to find the percentage, you say times 100%. So it means you will get 17 divided by 20, and then times the 100, you will get that is 85%. Ne? Let's move along. let's look at symmetrical and the skewed data. Okay, so it is important to be able to, okay, I forgot to mention something here. So there is something that you need to know, ne, before we can move along. So adding the same value or subtracting the same value from the data set, it doesn't change your standard deviation. Your standard deviation will still remain the same, even if you keep on adding the same value or keep on subtracting the same value from each and every value in your data set. For instance, in this data set, if I decide to keep on subtracting -3, -3, -3, -3 in each and every value, then my standard deviation won't change. It will remain the same. But if I keep on adding the same value again, it is going to remain the same. But with the mean, if you keep on subtracting the same value or keep on adding the same value, that is going to change the mean, depending on whether you are subtracting or either you are adding. So if I'm adding, it's going to increase the mean, and then if I'm subtracting, it's going to decrease the mean. Ne? So you keep on adding the same value or subtracting the same value, the standard deviation doesn't change. Put that in mind always, because they'll ask you in the exam. And then if you keep on subtracting the same value or adding the same value, that is going to change the mean. The mean changes, standard deviation doesn't change, remains the same. Are we together? Okay, so let's move to symmetrical and skewed data. So now you have sketched your box and the whisker diagram. You want to see how your data is distributed. So it is important to be able to identify symmetrical and skewed data. If there are items with very large or very small values compared to the rest of the data set, they will cause the data set to be skewed. So we've got 3 general rules to test if data set has been skewed. So after sketching your box and the whisker diagram, if it looks like this, or you can either look at your whiskers or look at your box. So this one, you can see that this box is symmetrical, or the data is normally distributed. But another way of checking, you can check your mean and your median. You can compare your mean and your median. I think that's the easiest method, because sometimes after sketching your box and your whisker diagram, you realize that you can't really see if it's skewed or not skewed. So it's better to just look at the mean and the median. So if your mean, it is equals to the median, then your data is normally distributed. Okay, and then number 2, if your mean, it is greater than the median. If your mean is bigger than your median, then it means your data has been skewed to the right. Again, if your mean is less than the median, or if your mean is smaller than the median, then your data set will be skewed to the left. Please make sure that you remember those rules. If data set is normally distributed, approximately 68% of the data falls within one standard deviation of the mean, and approximately 95% of the data falls within 2 standard deviations of the mean. Okay, let's quickly move to an outlier. I'll just do one example that is going to include the symmetrical and also your skewed data and your outlier. So remember, in our last lesson, I spoke about an outlier. I said an outlier is a value that is much larger or much smaller in a data set. So for instance, if you are looking at that data set, 3:35 is to 37 is to 38 is to 40 is to 42 is to 44 is to 76. If you check nicely, you'll see that 3 is an outlier because it's much smaller than the rest of the data set. And then also your 76, it is an outlier because it is much larger than your data set. So a value is defined to be an outlier if it fulfills one of the conditions below. So if the value is less than Q1 minus into 1,5 times the IQR, then we can say that value is an outlier. And then if the value is greater than Q3, which is your upper quartile, plus into brackets 1,5 times IQR, we can say that is also an outlier, because sometimes it is difficult to see an outlier. So it's better if you just use these two equations or these two formulas, which is the lower quartile minus 1,5 times the interquartile range, and then the upper quartile plus the 1,5 times the interquartile range, right? So we can use those two formulas to find our outliers. So let's look at example number 3. It says the table below shows the prime interest rate in South Africa from 2006 up until 2012. So you have the years and you've got the rates. Ne? So let's look at letter A. It says we need to determine the 5-number summary for the data in the table. So you are given your data set. It's 11, 13, 15, 14, 10, 9, and 8,5. Don't forget, for you to be able to find the 5-number summary, you should first arrange your data set in an ascending order or in an increasing order. So let's start with the smallest one, which is 8,5. And then we have 9. Then you have 10. Then you have 11. And then you have 13. Then you have 14. Then you have 15, right? Okay, so your 5-number summary, it includes your minimum value, which is going to be 8,5. It is going to have your maximum value, which is the biggest value in a data set. In that case, it is 15. Then it is going to have Q2, which is your median, if you still remember, your middle value. So if I check nicely there, okay, I would have 1, it's 1, 2, 2, 3, 3. So your middle value is going to be 11. So it is going to be given as 11. Don't forget, you can also use that formula that I taught you of finding the position. You say it's 1 all over 2 into, inside the bracket, you put the total number of terms plus the 1. Your total number of terms in this case is going to be 1, 2, 3, 4, 5, 6, 7. And then if you say 7 plus 1, you'd get 8. And then 8 divided by 2, you'd get 4. So it means your median is in position 4. So if you say 1, 2, 3, 4, you get your median as 11. Okay, and then we can also find our Q1, which is the lower quartile. Remember the equation of finding the lower quartile again. It's 1 all over 4 into n plus the 1. You can use that formula anytime, but I am not going to use that formula today, because we already know that the lower quartile, we are talking about the lower half of our data set. Ne? So the lower half of this data set, you exclude the median. So it is going to be 1, 2. It means we are dealing with this part only. Ne? So it's 1, then your median of your lower half, it is going to be 9. Okay, and then your Q3, which is the upper quartile, there you know that we are talking about your median of your upper half of your data set. So if I'm looking at my upper half of the data set, there it is going to be, this is the upper half of the data set, because you have to exclude the median. So you say it's 1, and then the middle or the median of that upper half is going to be 14. So in this case, it's going to be given as 14. So you have your minimum value as 8,5, your maximum value is 15, your Q2 as 11, your Q1 as 9, and then you have your Q3 as 14. Ne? Let's move to the second question. Okay, so the second question, they're now saying draw the box and the whisker plot for the data. Okay, I'll start it from 1. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Don't forget, when you're doing your box and your whisker plot, you can't just plug in your values, say this is the minimum value, it's 8,5, then you just say 8,5. This one is the Q1, so it's just maybe 8 if, sorry, maybe 10 if your lower quartile was 10. And then maybe here you say, okay, my median is 11, then it's just 11. And then you don't just plug in your values. You must have a Cartesian plane. And then in your Cartesian plane, you make sure that you've got a correct scale. Use a correct scale. Make sure the spaces in between, they are the same, ne? So that you can see your skewness of the plot or your skewness of the box and your whisker, ne? Okay, so I have my minimum value at 8,5. So 8,5 is going to be in between 8 and 9. So it's going to be here. So I put my whisker. And then I have my maximum value at 15. So here I'll have 15. And then I have my median at 11. So I have my median here at 11. And then I have my upper quartile at 14 and my lower quartile at 9. So it's 14 and 9. I'll have my upper quartile. And then I'll have my lower quartile. So it means your box is going to look like this. Can you tell if whether your box is skewed to this side or it is skewed to this side? I can't tell, but I can see that the box is longer this side if you look at it nicely. So it looks like it is skewed to the right, ne? It looks like it is skewed to the right, but I'm not sure. So what do you do if you are not sure? You go and you check your mean and your median. So my mean here, you just add all your values. Your X bar will be given as, you add your 8,5 plus 9 plus 10 plus 11 plus 13 plus 14 and plus 15, ne? And then you divide by the total number, which is 1, 2, 3, 4, 5, 6, 7, which is 7. So if I say 11 plus, just put everything in your calculator. I am getting 11,5. So my median, it's 11. Let's go back. Your median, your Q2, it is 11. And then your mean, it is given as 11,5. So it means the mean, it is greater than your Q2, which is the median, right? So if your mean is greater than the median, what does that tell you about the skewness of the data? Okay, let's go back to our notes and check nicely. So if our mean is greater than the median, it means that our data is skewed to the right, ne? So the next question, whereby they're saying comment on whether or not the data is skewed. So the data is skewed, it's skewed to the right, ne? Okay, and then the last question is now saying, are there outliers in the data? We don't know, right? But we can use our formulas to determine if whether we have outliers in the data. So I said the first one, it is going to be your Q1 minus 1,5 times your IQR. So Q1, we said it is given by 9, and then you have 1,5 times your IQR. It is going to be given as, you say, your IQR, it is given as Q3 minus your Q1, right? If you still remember. So your Q3 in this case, it is given as 14. And then your Q1, it is given as 9. So you say 14 minus 9, you'll get a 5. So it means you multiply that by 5. So anything that is less than this, it is going to be an outlier. So I have 9 minus into 1,5 times 5. So I'm getting 1,5. Do I have any value in my data set which is less than 1,5? No, I've got 11, I've got 13, 15, 14, 10, 9, and 8,5. So I don't have any number that is less than 1,5, right? And then also, it should be greater than your Q3 plus 1,5 times IQR. So your Q3, we said your Q3 is given as 14 plus 1,5 times 5 for the IQR. Let's put everything in the calculator. Then you'll get 14 plus 1,5 times 5. Then you'll get 21,5. So it means anything that is going to be above 21,5 is going to be an outlier. Let's go back to our data set. We check, do I have anything that is above 21,5? No, I don't have anything that is above 21,5. So for the questions which says, are there outliers in the data set? You say, no, you do not have any outliers because you don't have any value which is less than 1,5 and you don't have any value which is greater than the 21,5. Okay, so let's look at the last example, which is example number 4. Let's do it step by step. So A, it says determine the 5-number summary. B, draw the box and the whisker plot for the data. And then C, are there any outliers in the data? Determine the 5-number summary. I said to you, the first thing that you need to do is to arrange your data set in an ascending order. Ne? Okay, so we'll start with 2. And then do we have a 3? No. 4? No. 5? No. And then we have a 6. And then we have another 6. And then we have a 7. Do we have a 8? No. But we do have 11, 2 11s. And then I have a 14. And then I have a 21 and a 22. Ne? So when they say we must determine the 5-number summary for the data in the table, 5-number summary, you are starting with your minimum value. So the minimum value, it's the smallest value in the data set, which is going to be 2. And then the maximum value is going to be the biggest value in the data set, which is going to be given as 22. And then you have the median, which is your Q2, which is the mealy value of the data set. In that case, it's going to be 1, 2, 1, 2, 3, 3, 4, 4. It is going to be given as 11. Let me check. 1, 2, 3, 4. 1, 2, 3, 4. So the middle value there, it's going to be given as 11. But you can also use the formula that says 1 over 2 into n plus 1. And then it's going to be 1 over 2 into the total number, which is going to be 2, 4, 6, 8, 9 plus 1. Then it's going to be 2 over 2, sorry, 10 over 2, which is 5. So it means your median is in position 5. Let's double check. You have 1, 2, 3, 4, 5. Yes, it's in position 5 and it's 11. And then we move to Q1, which is your lower quartile. Q1, which is your lower quartile. I did say when we are talking of Q1, we are talking about the median of your lower half. So you can check your lower half there. Your lower half is given by this one. So you need to find the midpoint of that. And then the lower half of this side, it is given by that, and then you need to find the median of that. So here the median is going to be 6 and 6. So you'll say 6 plus 6 divided by 2 and you'll get 6, right? And then for Q3, or your upper quartile, it is going to be given as 14 plus 21. So it's 14 plus 21, you divide by 2. You'll get 35. So you get a mark, a mark, a mark, a mark, and a mark for... Oh, no. Made a mistake, forgot to divide by 2. So if you divide by 2, you'll get... You need to get 17.5. 14 plus 21 divided by 2, it is 17.5, ne? Okay. Let's move. And then B, it says draw the box and the whisker plot for the data. Let's do our box and a whisker. Let me use 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22, ne? Make sure, oh, this is 10. Okay, so my minimum value, it is going to be here as 2. My maximum value, it is going to be there as 22. Then my median, it is going to be here as 11. And then I'll have my upper quartile as 17.5. This is 17, so 17.5 is going to be somewhere here. And then I'll have my lower quartile as 6. So I construct my box. Construct your box. So I have my minimum value, I have my maximum value, I have my Q1, my Q2, and my Q3. If you are looking at this box and whisker diagram, you can see that it looks like the data is normally distributed, ne? Okay, but let's just check between the mean and the median so that we can see if our data is skewed or not skewed. So the median, it is given as 11, and then our mean, we have to add each and every data set and then divide by the total. So it is 14 plus 6 plus 22 plus 21 plus 11 plus 7 plus 2 plus 6 plus 11. Then you divide it by the total, which is 1, 2, 3, 4, 5, 6, 7, 8, which is 9. You'll get 11,11. So your mean is 11,11. So your mean, it is bigger than the median. So mean is bigger than the median. So it means your data set is still skewed to the right. Remember, you only check if your data is skewed to the right, to the left, or it's normally distributed if they ask you in the exam. Not that every time when you are done plotting your box and your whisker plot, you need to determine if your data is skewed. Only if they ask you, ne? You don't just do it. Let's move to the question of outliers. Are there any outliers in the data? So you must have your Q1, you must have your Q3, and then you must have your IQR for you to be able to answer this question, because we look at that data value that is less than Q1 minus 1,5 times IQR, which is the interquartile range. And then you must have the other one, which is going to be greater than Q3 plus 1,5 times IQR, which is the interquartile range again. So your Q1 here in this case, it is given as 6 minus 1,5. And then your interquartile range, you find it by saying this one is 6. It's 17,5. So you'll say Q3 minus Q1, which is 17,5 minus 6. And you'll get 11,5. So it means it's times 11,5. And then this side, you are going to have 17,5 plus 1,5 times 11,5. If you punch anything in the calculator, you'll get negative 11,25. So you need to check if you have anything that is less than negative 11,25. And then it's going to be 17,5 plus 1,5 times 11,5. And then you will get 34,75. Then you check for anything that is going to be above 34,75. Let's go back to our data set and check. Do you have anything that is above 34,75? No. Do you have anything that is less than negative 11,5? No, again. So it means, again, we do not have any outliers. So there are no outliers. Then you get your full marks. Okay. In summary, you should be knowing how to find your standard deviation using the equation, and also finding the standard deviation when you are using your calculator. And then symmetrical and your skewed data, there you must know that if your mean is less than the median, then it means your data is skewed to the left. If your mean is greater than the median, then it means your data is skewed to the right. And then if your mean it is equals to the median, then it means your data is normally distributed. Okay, and then in terms of the outliers, how do you find the outliers? So you must check if you have any value that is less than the lower quartile minus 1,5 times the interquartile range, and also if you have a value that is greater than the upper quartile plus 1,5 times the interquartile range. Okay, I made some worksheet for you from previous question papers. We've got the question 1 here. We've got this other question 1, and then you have this question 1, and then you have another question 1. I think we can take one question 1 and do it. Okay, let's take this question 1. With the time that we are left with, let's try to do it. You are given 5:8:15:20:25, 27, 31, 36, and 37. Everything has been arranged in an ascending order. So try to do, let's say, the first 4. Let's answer the questions. It says the table below shows the number of cans of food collected by 9 classes during a charity drive. Okay, so 1.1, it says calculate the range of the data. So remember the range, we said the range, it is given by maximum minus the minimum. So you take the largest value in your data set, you subtract the minimum value. So in that case, it's going to be 75 minus 5, which is going to be 70. So that one is just 1 mark. It is 1 mark. Okay, so you just get 1 mark for the answer. And then we move to 1.2. It says calculate the standard deviation of the data. So the standard, for finding the standard deviation, it's only 2 marks. Only 2 marks. There is no need to do the manual method. So let's just enter our data set in our calculator. So I said you must go to mode setup. And then in your mode setup, you go to number 2 for stats. and then you go to number 1. It's gonna give you a table whereby you can enter your data set. So you press 5 and then you press equal sign, you press 8, you press equal sign, you press 15 and then you press equal sign, you press 20, you press equal sign, you press 25, you press equal sign, you press 27, equal sign 30, 31, equal sign 36, equal sign, and then 75, equal sign. Then you press on or you press your AC. You'll realize in your calculator on top there is stat and then there is degree, right? So for you to access your data set, you'll go to shift and then you press 1. If you press 1, you are going to go to number 4, which is Varn. And then from there, since we are finding your standard deviation, you go to number 3, right? And then you press the equal sign, and for your standard deviation, you will get 19,56. So that one is going to be 2 marks. So it's just going to be 2 marks. And then we move to 1.3. It says, determine the median of the data. Median of the data, it's the middle number. Ne? So you go to your data set, you check which number is in the middle. So you've got 1, 2, 3, 4. Your data set will have 25 and 27 in the middle. Am I lying? Let's double check. It's going to be 1, 2, 3, 1, 2, 3. Then, oh, no. It's going to be 25. You can just double check by finding the position. Ne? You say the position of the median of Q2, it is equals to 1 over 2 into the n plus the 1. Ne? So it's 1 over 2, your n, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 plus 1. So it's going to be 10 divided by 2, which is 5. So it means your median is in position 5. You go to your data set, you say it's 1, 2, 3, 4, 5. You'll get that your median is 25. So don't forget, you can also use the method of just finding the position, but there are no marks for doing that. You only get a mark for finding the median. So for the median there, you'll get 1 mark. So that is going to be 1 mark. And then you move to 1.4, which says determine the interquartile range of the data. How do you find your interquartile range? So obviously you need to find Q1 first. And in Q1 you only find it where in your lower half of your data, right? So it's going to be the median of the lower half of your data. So if I check the lower half of my data, it's given the median of the data set is going to be 8 and 15. So it means you'd say it's 8 plus 15, you divide by 2. So you'll get 8 plus 15, you divide by 2, you'll get 11,5. And then you move to your upper quartile range, which is Q3. Q3, it is going to be given, we're looking at the upper half of your data set. It's going to be 31 and 36, right? So it's going to be 31 plus 36. You divide it by 2. It's 31. 31 plus 36. You divide it by 2. You'll get 33,5. You are not done. They said find the interquartile range. So you say the interquartile range, which is IQR, it is given as Q3 minus Q1. And then Q3 is given as 33,5 minus your Q1, it is 11,5. So you say 33,5 minus 11,5, you will get 22. So it means your IQR, it is given as 22. You have 3 marks there. You are going to be awarded 3 marks. So you'll get 1 mark for getting your Q1, and then 1 mark for getting your Q3, and then 1 mark for getting your IQR, and in total there is going to be 3 marks. So 1.5, 1.6, and 1.7, you will continue it at home. You will draw the box and a whisker diagram. Already you have everything there. You have your Q1, you have your Q3, you have your Q2. You also have your maximum and your minimum value, so you can just find your box and your whisker. And then when you are describing the skewness of the data, if you can't see your box and your whisker nicely, just check the mean and the median. Remember I said you can just compare the mean and the median, ne? Okay, and then 1.7, you have to identify outliers if any exist for the above data. Remember the two equations. If it's less than Q1 minus 1,5 times 1 interquartile range, and then it's greater than Q3 plus your 1,5 times your interquartile range, then it means it is an outlier. Okay, so please go home and just continue with the other worksheets. On top, I did put the dates for you, so if you are struggling with maybe finding the memo, you can go to November 2015 paper 2, and then you'll get the memorandum for those worksheets. Thank you for joining in. Don't forget, Matt, you only get it right if you practice. Thank you.